Section 8.2. In Section 8.2, we're going to be looking at the reference angles more closely. I've labeled all the reference angles in each quadrant. So this is quadrant 1, and again, theta is the reference angle. So the positive angle is equal to the reference angle in quadrant 1. Quadrant 2 is over here. So the reference angle considered to the positive angle, it's going to be 180 minus the reference angle. Quadrant 3, there's the reference angle again, and quadrant 3 positive angle is all the way over here, but if I want to get the reference angle and the positive angle, the positive angle would be 180 plus the reference angle. And finally, quadrant 4 is all the way over here, so it's going to be 360 minus the reference angle. So as an example, express the sine of 160 degrees as a positive acute angle. An acute angle is less than 90 degrees. So first I draw where 160 is. So 160 is in quadrant 2. So the reference angle is right here. So to calculate the reference angle, it's going to be 180 minus 160. I know that this measurement here is 180. So I get 20 degrees. And since the sine is positive in quadrant 1, the sine of 20, or the sine of the reference angle, will still yield me the same answer. I know sine is positive in quadrant 1 because of our chart over here. Sine is positive in quadrant 1. Express as a positive acute angle, cosine of 225 degrees. 225 degrees is in quadrant 3. In quadrant 3, cosine is negative. And again, looking back at our chart, cosine is negative. Here's quadrant 3, cosine is negative in quadrant 3. So the reference angle must be expressed as a negative. So when you find the reference angle is going to be 225 minus 180. That's going to give me this measurement right in here. Again, all the way around is 225, and the axis is 180. So if I do 225 minus 180, that gives me the reference angle. But since it has to be negative, I express it as negative cosine 45. I need the 45 degrees because the problem says find a positive acute angle. The positive is the 45. It's acute. I account for the sign difference of quadrant 3 by putting the negative sign out in the front. Another one, tangent of 324. 324 is all the way over here in quadrant 4. Tangent is negative in quadrant 4 if you look at your chart. Again, quadrant 4 right here, tangent is negative. The reference angle is going to be 360. Again, all the way around is 360. 360 minus 324 is 36 degrees. And again, since it's negative, I account for the negative out in the front. And the acute angle is 36 degrees, so negative tangent, 36 degrees. For the next part of section 8.2, please review section 4.3 video on calculator keystrokes to get angles, measurements on the calculator. And then finally, the last part of this wants you to find theta given 0 degrees is less than or equal to theta is less than 360, which means first of all your calculator is in degree mode because of that condition, and I need to find the value of sine theta equals minus 0.8049. Because this is negative, I have to see where sine is negative, which quadrants. Sine is negative in quadrants 3 and 4. So sine is negative in quadrants 3 and 4, so I need a quadrant 3 and a quadrant 4 angle to satisfy this condition. First thing I need to do is find the reference angle. Because I see theta and I have the ratio of the two sides as a negative 0.8049, I have to use inverse sine to calculate the reference angle. I want to use the positive number not the negative number. Otherwise, if I use the negative number, it's going to give me an angle other than the first quadrant. So if I take the inverse sine of positive 0.8049, it gives me quadrant 1 angle, which is the reference angle, at 53.6 degrees. Since I need quadrant 3 to get an angle in quadrant 3, right here, quadrant 3, positive angle is going to be 180 plus the reference angle. For quadrant 4, positive angle is 360 minus the reference angle. So a 180 plus 53.6 is 233.6, and 360 minus 53.6 is 306.4. So those are my two answers for this. Again, find theta in between 0 and 360. So this is also in degree mode for calculator. This time they want me to find the values of theta that will give cosine theta equal to 0.2624. This is positive. The 0.26424 is positive. So cosine is positive in quadrants 1 and 4. So I need a quadrant 1 angle and a quadrant 4 angle. Again, I see the theta symbol. I have the ratio of the two sides as 0.2624. So I have to take the inverse cosine of 0.2624. It's already positive, so I just leave it positive. That gives me the reference angle in quadrant 1 of 74.79 degrees. Because that's quadrant 1 angle, that is the positive angle that I need. So 74.79 degrees is one answer. Quadrant 4 angle is going to be 360 minus the reference angle, so that comes out to 285.21 degrees. Find theta such that the cotangent of theta equals a negative 0.543. Cotangent belongs with tangent. Tangent is negative in quadrants 2 and 4. It might be helpful if you have that page printed out while you're looking at this. The page I'm talking about, this page here, you should have printed out, and this page here, you should have printed out. So tangent is negative in quadrants 2 and 4. The first thing I want to do is get the reference angle. Again, it's inverse tangent. If you want to review your calculator keystrokes, how to get cotangent, we don't have that button on the calculator. So I have to do 1 over 0.543, and again, I'm making it positive so that I get the quadrant 1 angle out when I do the calculation. But inverse tangent of 1 divided by 0.543 is 61.50 degrees. That's my reference angle, that's my quadrant 1 angle. But for this particular problem, I need quadrant 2 and quadrant 4. So quadrant 2 is 180 minus the reference angle, quadrant 4 is 360 minus the reference angle. So quadrant 2 is 180 minus 61.5, so that's 118.5. And quadrant 4 is 360 minus 61.5, which is 298.5.